What if I told you that, by shrinking materials down to 1/1000th of a meter, we can completely change how they behave? Materials that look ordinary at our scales can become stronger, more reactive, or even change colors, just by becoming smaller. Welcome to the fascinating world of nanotechnologies, where tiny changes create massive impact. Nanotechnologies is the science and engineering of materials at nanoscales, typically between 1 and 100 nanometers. To put that into perspective, a single nanometer is 1/1000th of a meter. That's about 10,000 times smaller than the width of a human hair. At these incredibly small scales, materials don't behave the same ways as they do in our everyday world. Instead, they begin to follow a different physical and chemical rules, driven by the surface effects and quantum mechanics. And that's what makes the nanotechnology so powerful. So first, let's compare bulk materials with nanomaterials. In the bulk forms, materials usually have stable and predictable properties that we observe in everyday life. Gold, for example, appears shiny and yellow, while silvers look metallic and reflective. These properties remain relatively constant because the majority of atoms are located inside the materials, where they are less reactive and more chemically stable. But when we shrink these materials down to the nanoscales, something remarkable happens. Their physical and chemical behavior can completely change. Take gold as an example. At the nanoscales, gold nanoparticles can appear red, purple, or even blue depending on their size and shape. This happens because the nanoparticles can interact with light differently through a phenomenon called the localized surface plasmon resonance, where electrons on the nanoparticles surface oscillate in response to light. Another major reason for these unique behaviors is the drastic increase in surface area to volume ratios. As the particle becomes smaller, a much larger percentage of the atoms are exposed to the surface instead of being buried inside the materials. Surface atoms are more chemically active, meaning nanomaterials became more reactive and responsive to their environment. This increased surface activity gives nanomaterials many enhanced properties compared to the bulk materials. They may become stronger mechanically, more electrically conductive, more catalytically active, or more sensitive to chemicals and biological molecules. So at the nanoscales, materials are no longer just smaller versions of bulk materials. Their behavior fundamentally changes. In short, sizes changes everything. Nanomaterials are classified based on their dimensions. Zero-dimensional materials, or the 0Ds, are nanoparticles. Their all dimensions are in nanoscales. One-dimensional materials like carbon nanotubes have one extended dimensions. And two-dimensional materials such as graphene are ultra-thin sheets, just one atom thick. As dimensions decrease, surface area increases dramatically, and this leads to enhanced reactivity and performance.
Nanotechnology is not just a laboratory concept. It's already part of our daily lives. In healthcare, nanoscale biosensors are transforming how we detect diseases. These sensors can identify biomarkers like glucose or proteins at extremely low concentration. Wearable devices, such as smart patches, use nanomaterials like graphene to monitor health signals in real time, including heart rate, temperature, and even sweat composition. In sunscreen materials, nanoparticles like zinc oxide and titanium dioxide provide strong UV protection. Nanotechnology is also widely used in antibacterial coating. Silver nanoparticles release ions that damage bacterial cells, disrupt DNA, and prevent reproduction. Another powerful application is in advanced diagnostics using localized surface plasmon resonance. These techniques use metal nanoparticles that respond to light. In materials science, nanotechnology is enabling the development of extraordinary materials like graphene and carbon nanotubes. Graphene is a single layer of carbon atom that is incredibly strong, flexible, and conductive. Carbon nanotubes share similar properties and are used to improve strength and performance in many applications. These nanomaterials are already being used in flexible electronics, energy storage devices, and lightweight engineering materials. From invisible coatings to life-saving diagnostics, nanotechnology is already shaping the world around us. And as research continues, its impact will only grow, unlocking new possibilities we are just beginning to imagine. But how do we actually create nanomaterials? There are two main approaches: top-down and bottom-up. In the top-down approach, we start with bulk material and break it down into nanoscale structures. A key technique is lithography, used in most semiconductor manufacturing. This transfers extremely small patterns onto the surface. Next, etching processes. Etching processes will remove unwanted material. When etching, use acid as a chemical solution to remove outer surface, while dry etching use plasma or gases for higher precision. These methods allow us to create features just a few nanometers in size. In contrast, the bottom-up approach builds materials atom by atom. In chemical vapor deposition, or CVD, gases react on a heated surface to form thin solid film. Physical vapor deposition, or PVD, works by vaporizing solid materials and depositing onto the surface as a thin layer.
So let's take a look at how nanotechnology is actually used in real industry, especially in making semiconductors. This is where things get really precise. One important process is called ion implantation. Basically, scientists shoot tiny charged atoms into a material to change how it behaves electrically. This is known as doping, and it's what allows us to control how a semiconductor works. Another key method is thin film deposition. Here's layers of the material are added one by one, but we are talking about layers that are only a few nanometers thick, so that it's insanely small. By stacking and controlling these layers so carefully, engineers can build microchips, sensors, and nanoelectronics from this whole process. And these are the things that power pretty much everything that we use today, especially for phones, laptops, or even the smart device that we are using at home. Now, once we have created something very small, so how we can see it or how we can characterize it. So that's where the advanced tools come in. First is the SEM, or scanning electron microscopy. This lets us see the detail of the surface and image way beyond what normal microscope can do. Then there is TEM, which going even deeper, it can actually show how atoms and the structure are arranged inside the material. We also having AFM, or atomic force microscopy. This one is very cool that it scans surface of the structure and create a 3D map at the nanoscale, almost like feeling the surface instead of just looking at it. On top of that, there are the spectroscopic techniques like Raman and FTIR. So these two techniques help us to understand the chemical structure and basically what bonds and molecules are present. Another technique we call UV spectroscopy tells us how the material interact with light, and tools like the synthesizers can measure particles, size, and stability in liquids. So all these tools help us to study a world that we literally cannot see with our eyes. Looking ahead, nanotechnology has some very exciting potential. In energy, it could lead to better batteries that last longer and charge faster, as well as more efficient solar cells panel. In medicines, one of the biggest ideas is target drug delivery. That means medicine could go directly to the exact cells that we needed, and making a treatment more effective and reduce side effects. And for the
environment, nanotechnology could help clean waters and remove pollutants more efficiently. And yes, it's not about just the tiny material, it solves the big real world problem as well. At the end of the day, nanotechnology isn't just about making things smaller. It's about discovering new behaviors at the small scales and using that technology to improve the life qualities and how we are doing in the world. For healthcare, to energy, to everyday technology, nanotechnology is already shaping in the future, 1 nanometers at the time.